Alright, so this time we're doing problem 27 from chapter 5, and the question says, a stockroom worker pushes a block with a mass of 16.8 kilograms on a horizontal surface at a constant speed of 3.5 meters per second. The coefficient of kinetic friction between the box and the surface of the floor is 0.20. Part A, what horizontal force must the worker apply to maintain this motion? So, start off, we know that the sum of the forces is going to be equal to the mass times the acceleration. We want it to stay at this velocity, so we know that this is going to zero, so the whole thing will be zero. So we're going to have the force that the worker is pushing with minus the force of kinetic friction. It's going to be equal to zero, so that force is going to be equal to the force of kinetic friction. We know how to solve for this because we know that that is going to be equal to the coefficient of friction times the normal force. So that's going to be U of kinetic friction times mass times the gravity. And so we just plug on all the variables. The force is going to be equal to 0.2 times 16.8 times 9.8. And that gives us a force of 32.9 newtons. The next part of the question then says, if the force is calculated in part A is removed, how far does the box slide before coming to rest? And this is going to require a bit more. So it's going to require us using two different equations. So this equation then becomes the force of kinetic friction is equal to mass times the acceleration. We're also going to have to use the equation that velocity squared minus the final velocity minus the initial velocity squared is going to be equal to 2 times the acceleration times the distance that it travels. And that's what we're looking for, is the distance. So if we solve one of these for acceleration, so the frictional kinetic friction divided by the mass is equal to the acceleration, we can then input this in for A here. So velocity squared minus U squared is going to be equal to 2 times the kinetic friction, the force of kinetic friction times the mass times the distance. So we know the initial velocity, we know this, we know the final velocity goes to 0, we know the initial velocity doesn't go to 0. I don't know why I did that. And so we can solve for this. So we just kind of plug everything in. So we know that it's S is going to be equal to U squared divided by 2 frictional coefficient of friction times the mass, which is then going to be equal to our initial velocity, 3.5 squared divided by 2 times coefficient of friction times mass times times gravity divided by mass. So the masses cancel out. And it's just the coefficient of kinetic friction times gravity. So that becomes 3.5 squared times 2 times 0.2 times 9.8 for the distance. So the distance, when you do the math, comes out to 3.125 meters. So 3.13 meters is your answer for the distance.